Hello and welcome to another Math with Miss V. In this video, we are looking at proportional versus non-proportional relationships. So who's being consistent? So here we will define what it means for numbers to be in a proportional relationship and how to tell if sets of numbers are proportional or not. So what is a proportional relationship? Well, something is proportional. It's the term we give when the relationship between ratios is a constant rate. We can call this many different things. We call it being proportional. We call it having a constant rate of change, or we say that they have the same unit rate. And that's what we're going to focus on. So how to tell if ratios are proportional? The easiest way is to check the unit rate. If they have the same unit rate, they're proportional. So for example, 4/2 and 10/5 both have a unit rate of 1/2. So they are proportional. If the unit rates are different, they are non-proportional. For example, 4/2 and 9/3, the first has a unit rate of 2/1, but the second has a unit rate of 3/1. So these are non-proportional. You can also tell by creating a graph, but this will be discussed in a later video. So let's look at these examples. Are they proportional? Do they have the same unit rate? So let's jump right in. We have 48/12. So we want to find its unit rate, something over 1. So we're going to divide both by 12. Divide by 12. 48 divided by 12 is 4. So my unit rate is 4/1. For my next one, I have 32/8. Again, we're looking for our unit rate, which is over 1. I'm going to divide both by 8. 32 divided by 8 is 4. So these are proportional. My next one, 50/25. We're looking for its unit rate, something over 1. To turn 25 into 1, I divide by 25. 50 divided by 25 is 2. My next one, 45/20. We're looking for my unit rate of 1. I'm going to divide by 20. So 45 divided by 20 is 2.25. So these are non-proportional. They have different unit rates. So let's look at a few examples with word problems. So Sally opens a new savings account. She puts $40 in the bank every week. Is the amount of money proportional to the number of weeks? Okay, so in this case, we want to make a chart to organize our information. So we're going to make what's called a T-chart because it looks like a very large capital lowercase t. And on one side, we're going to put the number of weeks. And on the other side, we're going to put how much money she has in her account. So always start at week 0. She opened a new savings account. Okay, so did she start with any money? And the answer is no, she didn't start. So she started with $0. Then after 1 week, she deposited $40. She put $40 in every week. So she had 0, she put $40 in, so she had $40. At week 2, she put in another $40, so 40 plus 40 is 80. And at week 3, she put in another $40, so 80 plus 40 is 120. So now we check the unit rates. So is the amount of money per week proportional? We ignore the 0 week because we cannot change a 0 into a 1. So let's look at week 1. 40/1 is already in a unit rate. So we'll check week 2. 80/2. Well, it's not a unit rate, but we can divide both by 2. and get 80 divided by 2 is 40. So 40 over 1. Those are the same. And the last we check is 120 over 3. We're going to divide both by 3 so we can get our unit rate to a denominator of 1. 120 divided by 3 is also 40. So is the amount of money she has proportional to the number of weeks? And the answer is yes, it is proportional. Okay, we're going to look at another example. Mark opens a new savings account, and as a reward, the bank will put $50 in his account. He puts 15 in the bank every week. Is the amount of money proportional to the number of weeks? Okay, so we're going to start with our T-chart again. Again, we're going to have weeks compared to money. Now, at week 0, Mark didn't start with no money. He started with $50 because they put it in as a reward. So he started out with 50. Then he puts in $15 every week. So after week 1, he's put in $15 and he has $65. Week 2, he's put in another $15 and he has $80. Week 3, he puts another 15 in and he has $95. Okay, and week 4, he would have $110. So is this proportional? Again, we ignore the 0 week and we start with week 1. So $65 to 1 week. This is already in a unit rate. My denominator is 1, so I need to look at my week 2. $80 to 2 weeks. Okay, I'm looking for my unit rate, so I'm going to divide by 2, divide by 2. 80 divided by 2 is 40. And we can see these are already different, so I don't need to keep going. This is the amount of money proportional to the number of weeks, and the answer is no. His money is not proportional. Okay, the last thing we want to look at are some charts. So how we can check a chart to see if it's proportional. And it's actually easier than it might seem. All we do is find the unit rate for each section. So what I like to do is to add another set of rows to the bottom of my chart for the unit rate. Okay, so 398 over 2. We would divide the 398 of 2 to get our unit rate. And we'd get 199 per 1. We would do the same with 3, and we'd find it's 199 per 1. 4 gives us the same thing, 199 per 1. 5 gives us the same thing, 199 per 1. And 6, we actually find out, gives us something different. It doesn't give us 199 per 1. It gives us 174 per 1. Excuse the bell. And so we can see this is not proportional or non-proportional. Let's look at one more example. Is this proportional? So we would add another section for our unit rate. And we would divide 62 by 2 and get 31 per 1. We would divide 155 by 5 and get 31 per 1. We would divide 248 by 8 and get 31 per 1. But we would get to 10 and we would see it would be 32 per 1. So this is also non-proportional. If it's proportional, it would have the same unit rate all the way across. So thank you for checking this Math with Ms. V video. I hope it has helped you out. Look forward to seeing you in the future.